The topic is computer languages. So this could be different languages such as machine language, symbolic language, and high-level languages. We'll see details about it. So first, let's start with the machine language that we call it as even low-level language. So this you can see right-hand side bottom of it, all zeros and ones. So this we call it as a binary code. So the language, that means language, when I say what it means, any instruction that is used to communicate with the hardware, that is a computer. So we communicate with the hardware that we have seen just now, CPU and all, right? So this CPU, main memory, CPU, we are going to communicate through this binary data. That is, we call it as a machine level language. Whatever the instructions or data, those are finally converted into this binary machine code, and those through using this machine code, that for example we have seen instruction like add r1 comma r2, let us say. So this instruction is finally going to converted into zeros and ones, and these zeros and ones computer will understand, and taking that zeros and only it will perform this operation instruction, right? They are basically directly executed by the CPU. You can see example instructions are here. So it looks like this machine code, machine level language. So they are basically fastest, but we cannot easily understand this, what it means. What is, we can see here, add r1 r2, you can easily understand because it's a human readable language. So add means addition, r1 r2, register 1, register 2, it's easily understandable. But can you understand these zeros and ones? Definitely no. So these are hardware dependent, means whatever the code I develop these zeros and ones, it is only for particular hardware one. So the same code I cannot run in the other hardware tool, let us say, right? You need to develop a different machine language for different hardware. That's the meaning of machine hardware dependent. So the next category of languages are symbolic language. Also we call it as a low level assembly language. This is also kind of low level language. Let's see how it will be. This we have already seen machine language. This is machine language, and you see here assembly language. Okay, assembly language. So you can see here there is an instruction called load b to the r1 and load h to the r2, and multiply, mul means multiply r1 or r2, and divide this r1 with the value 2, address it value 2, whatever it is, and return the results. Let us assume these are the some instructions. So these are basically uses mnemonics instead of binary. It is a binary earlier. Now mnemonics are used. Add, load, so on, so multiplication, division. So these are the mnemonics, right? So each instruction they are going to map to the again finally to the machine instruction. Okay. Each instruction is converted into, as I said, zeros and ones only finally. This is been there. But what is the advantage of this? Human readability. We can easily understand, a programmer can easily understand and write the program as per the requirement. So this requires a translator, an assembler we call it as. Don't worry what is that assembler, I'll tell you in the next classes, right? So this requires an assembler. This converts this assembly language into machine language. So assembly language into machine language, this is conversion. Assembler will do that, right? So this is, as I said, it's a low level language. So this is readable than binary. So you can see here it's all better. You can read when compared to this binary. You can easily read this above one, read and load multiply code. So this is how symbolic language looks like. Then next we had this, we have seen this is the assembly language, and this is your machine language, right? And all zeros and ones, these are the mnemonics used here. Next we had high level language. So high level language, let us say some language, don't worry what this language is. This is more readable than the assembly language, more readable. Okay, you can see this class, it's almost human, similar to human language. Class, you know, triangle, you know, float, you know, surface, you know, return, you know, this multiplication operation, you know, right? So these instructions are almost closer to the human language, and they are basically portable across the systems. What does it mean? Whatever the code you write using one system, the same code can be run on the different systems, and the same code can be executed on the different systems. Okay, that's the meaning of it. When it comes to this machine language, what I said, hardware dependent means these instruction only in one hardware. If you want to write other, if you want to run on other hardware, you need to write different instructions. Okay, different instruction need to be run. That here in this high level program case, whatever you write, and that is can be run on the any other independent other systems. So this needs compiler or interpreter. Earlier I said this need an assembler, and here it needs a compiler or interpreter. Okay, we'll see what does it mean by compiler, what does it mean by interpreter, what does it mean by assembler. Don't worry, I'll explain in forthcoming classes. Now, what are the examples for this high level languages means whatever language we are learning, C language and Python, Java, and whatever the language we learn like Python and so on. So these are the high level languages.